Okay, so I'll be talking about our most recent work, which is titled ReTRACe, which is meant for rewriting messages in blockchains. Uh, and this work was done with my colleagues Gaurav and Jay from the CS department, and it has been supported by federal agencies, the NSF and FAA, and also Intel Labs. Uh, so what we designed here is a system, or rather a framework called as ReTRACe. The point of ReTRACe is it helps us to rewrite blockchain messages, but at a fine-grained level, specifically at the level of individual transactions. And it does so in a way such that we ensure access control. The people who are rewriting the transactions are indeed authorized to do so, and it's not just anyone rewriting anything. And we can also trace the identity of people who have rewritten a given transaction if the need arises, like if it has been maliciously rewritten or something like that. In the course of designing ReTRACe, we discovered that we also need to design a few cryptographic primitives which serve as building blocks for ReTRACe, because the kind of cryptographic protocols that we needed for building ReTRACe simply did not exist at the time when we were building ReTRACe. One of them is called, it's technically in the paper it's called RFAME, but really it is a ciphertext policy attribute based encryption scheme. Uh, a ciphertext policy attribute based encryption scheme is, well, it is an encryption scheme, but it differs in very important, significant ways from traditional public key encryption schemes. In traditional public key encryption schemes, you always know who the person is who's going to decrypt a given message, right? Because you encrypt it using the public key of the decryptor. But CPABE scheme actually allows us to encrypt messages without caring about who's going to decrypt the identity of the person who's going to decrypt it, as long as we ensure credibility that it's the right person who decrypts it. For example, you could encrypt some things with a policy saying, only decryptable by a valid member of the CS department and a valid faculty member in the CS department at NMSU. And beyond that, you don't have to care about who's decrypting it, as long as you know that the decryptor is a member of the CS department faculty at NMSU. Uh, that's one thing we had to design while building ReTRACe. And we also had to design a revocable chameleon hash with ephemeral trapdoor scheme. Uh, Broadly, the chameleon hash with ephemeral trapdoor scheme is what helps us actually create collisions in the pre-image of a digest posted on the blockchain. Uh, just plain chameleon hashes with ephemeral trapdoor schemes existed before we designed ReTRACe, except that none of the existing schemes provided us the property of revocability. In other words, if you give someone the trapdoor, they have it in perpetuity. Uh, and so we had to design these two new cryptographic primitives along with ReTRACe, and both of them could be of independent interest, even beyond the scope of ReTRACe. So when we think about blockchains, the immediate picture that comes to mind is, well, a distributed ledger, which has the property of being append only. Uh, the most common application of blockchains that comes to mind is financial applications, right? Like two parties wanting to transact, one wanting to pay the other, but without having a centralized entity such as a bank or some trusted third party or an escrow agency, etc. The blockchain really serves as the trusted third party, the escrow party in the picture. And the idea is, once you write a financial transaction to the blockchain, a financial agreement or something, beyond once it's posted to the blockchain, posted and confirmed on the blockchain, it can never be updated after that. You can only append stuff, but you can never delete stuff or take stuff out of the blockchain. That is the picture that comes to mind. And that is indeed how most blockchains work. And immutability is an important property of blockchains. Uh, but there are certain situations where we actually would need to go in and delete or redact or even remove stuff from the blockchain. We'll talk about it in the next slide. This slide just shows, that the number of patents in the blockchain area has increased almost at an exponential level. That's the bottom graph. If you look at it, it shows the number of patents filed, just blockchain patents, not necessarily rewritability or anything, just general blockchain patents. In 2018, 2019, 20, and 21, if you plot the graph, the number of patents, that is almost an exponential curve. And then there are various types of, currencies associated with blockchain. Bitcoin is the most popular one, but there's Ethereum, there's Zcash, Monero, and lots of other stuff too. Okay. So in the last slide, we made the point that a blockchain is an append-only ledger, and the transactions posted on the blockchain are immutable. But there could be some situations where we do need mutability of transactions. One example is the R3 consortium, which is the example we also gave in the paper. R3 is basically a financial consortium which is built of various banks, and they have a permission blockchain called CODA, and it is permission because it's only the member banks of this consortium that have any read-write privileges to the CODA blockchain that they share. In such situations, it is not hard to imagine a situation where we have a malicious employee that maybe on the last day of work or something just posts some privileged information to the blockchain, which then needs to be later we need to go in and remove it. And there is also the danger of customers' PII, that's personally identifiable information, which the banks do have access to, either maliciously or otherwise getting or even accidentally getting posted to the blockchain. And there is also, and as we know, the Bitcoin blockchain has like lots of spam. The number of spam transactions in the Bitcoin blockchain itself, not even counting things like CODA, is in the order of thousands, if not millions. With spam, we can still say that let's just spam or objectionable content, which is already there in the Bitcoin blockchain. We can just say let's ignore the spam or the objectionable content. But when somebody's PII gets posted maliciously or accidentally on the blockchain, we cannot just say let's ignore it and let's just leave it there. We have to find a way to actively go in and remove that personally identifiable information from the blockchain, which is the purpose that ReTRACe serves. And then there is also this also ties into the GDPR of the European Union, and also in the US there is the CCPA, the California Consumer Protection Act, which was passed I think recently in the late I think in 2018 or something, which mandates that which mandates the GDPR mandates the right to forget that a user can request that any PII, personally identifiable information of theirs, has to be removed from, let's say, a bank's servers or blockchains that they share, etc., after the user ceases to be a customer of the bank, basically wiping off all personally identifiable information. And there could be penalties for financial institutions that actually, that actually do not comply with GDPR or wipe off users' data on request. And so for all these reasons, we do need a mechanism to rewrite or redact or remove data that's posted on the blockchain in certain situations. In other words, we sometimes do need mutable transactions. The left part of the slide just talks about the underlying cryptographic primitives that we use. We use actually 3 primitives. One is chameleon hashes, the other is attribute-based encryption. We won't get into the details of that. But the point is the existing chameleon hash scheme and the existing attribute-based encryption schemes, there are several that are out there. It's just that none of them provided the property of revocability that we needed, which is why we had to design revocable chameleon hash schemes and revocable attribute-based encryption schemes. And there are a couple of revocable ones, but they have various technical problems besides being inefficient and all that. The right part is what is a little bit more relevant. There is already existing work in the area of, and it's pretty recent, as we can see from the years mentioned there. From 2017 onwards, people have been looking at blockchain rewrites, and attorneys et al. Have also patented their approach. But the point is, the existing methods of doing blockchain rewrites only do rewriting at the block level. For example, the Bitcoin blockchain has around 4,000 transactions in a block. And if we want to go and rewrite a single transaction, maybe because it contains somebody's PI, personally identifiable information, or maybe just spam, or for whatever reason, if you want to overwrite a single transaction, we're going to have to rewrite the entire block consisting of, like 4,000 transactions, which is not very optimal. So that is and our work ReTRACe, it actually allows us to do fine-grained transaction level rewriting. If you want to rewrite a single transaction in the list of 4,000 transactions, you just go in and write that one thing and don't worry about other, you don't have to worry about rewriting the entire block. That is one advantage. And also our approach also provides revocability. That is, if someone has the privilege, for example, an employee of a bank has privilege to go and rewrite transactions, intuition tells us they should have that rewriting privilege only as long as they remain an employee of the bank for work, and they need to use the rewriting privilege only for work purposes, not for, once they cease to be an employee, they shouldn't, that privilege needs to be revoked. Revocability was also not provided by prior works. As we said before, in prior works, if someone had a privilege to rewrite transactions, they had that privilege forever, for eternity. And since revocation is easily motivated from a practical standpoint, that was one of our motivations in designing ReTRACe. And now, okay. Now comes the question of, sorry. Now comes the question of who can ReTRACe help. ReTRACe can basically help any company that deals with user data, for the company to provide some kind of proof that they are actually dealing with the user data, the user's personally identifiable information in as prescribed by the norms, and are not selling the data or using the data in any in a way that the user does not want them to. It can also help, it can greatly help GDPR compliance by companies, and it can also help the companies prove to the user that, it can also help the companies comply with GDPR requests by the user. That is by far the biggest application of ReTRACe, beyond the ones that we just mentioned, like rogue employees posting the posting PII and those kind of things. This is a little bit about the results that we have from. There are more results in the paper, but I'm just going to talk about two ones that seem interesting. The first table on the left, it just shows us the timings in seconds for all ReTRACe operations. All the names there: user setup, keygen, create message, sign, verify. They're all algorithms comprising the ReTRACe framework. And the thing to note here is all the timings here are in the order of seconds. So, and compared to like regular block confirmation times and all in blockchain, which are in the order of minutes, none of the operations in ReTRACe take more than 5 seconds, and some of them are even in the order of like milliseconds. And the one on the right just shows us how well our scheme compares with prior work. So we did mention that there is already prior work in the area of like chameleon hash schemes, except that the prior work does not provide the property of revocability. We do provide the property of revocability, and we're doing it almost for free. So the thing to note in the table on the right is there's not much of a difference between our chet, which is the revocable chameleon hash, and the non-revocable chameleon hash, which is just plain chet. Security usually doesn't come for free, right? But we have managed to add the revocability property at literally no cost, virtually no cost. Okay, I think I'm almost at the end of my time. We just have this one more slide, and then I'll stop and then take questions. So what's the current status of ReTRACe? First off, we have proposed a framework called ReTRACe, which can help us rewrite blockchain transactions, but at a very fine-grained level. And it also provides us, the property of revocability. That is, people should have rewrite privileges, even if it's even for transactions, only as long as they're authorized to, like we just said, like as long as they remain the employee of a bank or whoever is running a permission blockchain, or a company or university or whatever. And once they leave, their rewrite privileges should get revoked. And in the process of designing ReTRACe, we also designed 2 new cryptographic primitives: revocable ciphertext policy attribute-based encryption, and revocable chameleon hash with ephemeral trapdoors. And both of these schemes, bullet point number 2 and 3, they are of independent interest. They are they have way more applications even beyond just blockchain rewrites. They are of independent interest to the cryptography community. And what comes next? There are technical refinements that could be made in ReTRACe. One of the things about ReTRACe, it's very, the protocols and all are very math intensive. So all these algorithms here, on the left table, the user gen, from user setup up until the revoke user, they all use very heavy cryptographic machinery. It has to be that way, otherwise, we won't get the properties we want. But there's still some optimizations and technical refinements that we can do to make them a little less math intensive and a little more how do you say it, accessible, accessible to people who have allergies to math. But yeah, optimizing them and making technical refinements is definitely on the agenda. And for that, we know exactly what to do. We know the point. We have identified points where things can be, technical refinements can be made. The other thing that we actually haven't started exploring is, like we said, this chameleon, the CPAB scheme and the chameleon revocable chameleon hash with ephemeral trapdoor scheme. The point number 2 and bullet point 2 and 3 have way more applications, much beyond the scope of ReTRACe. ReTRACe is just one application. There are several other things. One thing that comes to mind is sanitizable signatures. Revocable CPAB schemes have applications in edge computing, edge and I think fog computing. So both of these primitives have way more application than just ReTRACe. So that's another very interesting area to to explore what independently can be done with the new primitives that we have designed.
Great. Well, thank you, Roopa, and we will look to our panel to see if there's any questions.
Matt, I would have a question.
Yes, go ahead.
Okay. So thank you, Roopa. Could you please help me understand the following? In my opinion, the original intention of blockchain is to create something that cannot be revoked and cannot be rewritten and is completely decentralized, and there is nobody who has special rights to do something which others don't, including also make changes. And now you are creating something that seem to undo these advantages of the original blockchain. And I fully understand why you are doing it, because of GDPR, CCPA, etc. But why do we need a blockchain at all in situations where rewriting and revocability are important?
Okay, so a blockchain fundamentally is a distributed ledger, and the situation where a blockchain is most useful is where we have a group of parties who are mutually untrusting. So for this bank example, if one bank could just run a centralized database, store all the customer information, and everybody trusts that that bank is, it's proper and it won't maliciously like modify information and all, then we don't need a blockchain. But I think the point of a blockchain is we have a group of people who are mutually untrusting, and there is no centralized database or anywhere to store stuff. And the blockchain is the only place where, you can store data in a way that proves in a way that gives provenance of the data. Nobody has maliciously gone and done modifications and all that.
I'm going to follow up because I don't see this as a problem. It looks like you're trying to solve something that really isn't a problem, because everybody wants that distributive ledger to not be able to be changed. So can you help us understand the problem?
Okay, the problem is we basically have a group of untrusting parties, which automatically rules out things like one person has a centralized database where they store everyone's data and all that. And if we take this bank example, we have a consortium of banks, nobody trusts each other. And the only way, and since there's no centralized database, the only place where they can store all their, their transaction data, even if it's a permission blockchain, is on a blockchain. And at this point, if we have, a certain bank has a malicious employee that posts users PII, personally identifiable information, or even, some privileged information that they have access to during the course of their work. If it's just spam, we can ignore the spam and not worry about it. But if somebody's PII or something gets posted, like credit card information, social security number and all that, or some, for GDPR purposes, we cannot just ignore it and let it be on the blockchain. We have to find a way to remove it. And, for systems that use ReTRACe and other rewriting methods, we could have every transaction needs to be put into two bins, mutable and immutable. The financial transactions, which obviously should not be modified, will be put into the immutable bin, whereas other transactions could be transactions that you can anticipate may need future modifications, could be put in the mutable bin. I think in the ReTRACe, we actually had, I think we had discussed in the paper, we had discussed that all transactions need to come with a flag like mutable or immutable.
Thank you.
Thanks, Dr. Vishwanathan. If you have additional questions, please message her or put some questions in the chat.